Hi everyone, this is the 74th video of the ACT Math Practice Problem series, and here we have a nice problem from the concept of complex numbers. As I always recommend, before seeing the solution, you can pause the video and give it a try yourself, and after that of course you want to match with my solution. So let's get started. Here the question says that if I, which actually stands for iota, so if I is equal to square root of -1, then the value of I to the power 5 plus I to the power 10 plus I to the power 15 plus I to the power 20 is which one of the below ones, right? So we have to find out the value of this expression. Now before we start calculating the value of this expression, let's try to find out what is the value of different powers of iota. So suppose iota to the power 1, so let's write it like this: iota to the power 1, which is actually iota itself, that is equal to square root of -1. And if we say iota squared, that would be square root of -1 squared, and that would be equal to -1. And if we say iota cubed, well, iota cubed would be iota squared times iota, so that would be -1 times iota, and that would be negative iota. And then if we say iota to the power 4, that would be what? Well, that would be iota squared times iota squared. We can think of it like that, and that will be -1 times -1, and that would be actually +1. So now what is our given expression? Well, the given expression is like this: it's iota to the power 5 plus iota to the power 10 plus iota to the power 15 plus iota to the power 20. So if you look at each of these terms in the expression here, right? So the first term can be written as iota to the power 4 times one more iota, that will make it iota to the power 5. Similarly, on the second term, what we have? On the second term, we have iota to the power 10. So can we write it as iota to the power 4 times iota to the power 4 times iota squared? And similarly, the third one can be written as iota to the power 4 times iota to the power 4 times iota to the power 4 times iota cubed. And the fourth term can be written as iota to the power 4 whole to the power 5. Because we have iota to the power 20, we can write it like that. Now from here, let's substitute the values of different powers of iota. So here in the first parenthesis, it would be iota to the power 4, that is equal to 1. Iota to the power 4 is actually equal to 1. So it would be 1 times iota, that means it will be iota, plus here it will be iota to the power 4, which is 1. So 1 times iota squared. So that would be 1 times iota squared is actually -1. So that would be actually 1 times -1. So we can say, well, this is actually -1 then. Plus in the third parenthesis, what we have? We have iota to the power 4, iota to the power 4, iota to the power 4. Those are all positive ones, but iota cubed is actually negative iota. So for the third parenthesis, we are going to get a negative iota. And then for the fourth parenthesis, what do we get? Well, this is actually 1 to the power 5, because iota to the power 4 is actually +1. So that will be actually 1 there, right? So then what we have then finally? We have an iota, then we have a -1, then we have a negative iota, and we have a +1. And if you look at it, the positive iota and the negative iota, they're going to cancel each other, and then the -1 and the +1, they're also going to cancel each other. So we are going to be left with a value of 0, and that is our answer. And if you look at our answer options, we have 0 under option K. So option K is the correct option. The easiest way to solve this kind of problem is to, remove any multiple of 4 from the power of iota. From the exponent of iota, you want to eliminate any multiple of 4. Right? So then can we write it like this? This iota to the power 5 right here, I'm just writing on the top line there. So iota to the power 5, can we write it as iota to the power 1? Because if we remove a multiple of 4, we have 5 there. So 5 is actually 4 plus 1. So if we remove 4, we will be left with 1. Now why are we removing 4? Because iota to the power 4 gives us +1. So it's as good as not even being there anymore, right? So whether you consider the iota to the power 4 or you simply ignore it, it's still the same thing, because +1 does not make any difference. So similarly, from the second term, we can remove 2 multiple of 4, that would be, we can remove 8, so we are going to be left with iota squared. And then from the third one, we can remove 3 multiples of 4, we can remove 12 from the 15, so we are going to be left with iota cubed. And similarly, from the fourth term, we can remove 5 multiples of 4. So we are going to be left with iota to the power 0. Now, if you think about it, this is actually a sum of 4 consecutive powers of iota, right? So sum of 4 consecutive powers of iota is actually equal to 0. You can try it yourself. It will be equal to 0. And that is why we also got the answer 0. So 0 is the correct answer. If you ever see an expression which looks like a sum of 4 consecutive powers of iota, meaning in this case it is 0, 1, 2, 3, right? So that type of an expression's value will always be equal to 0. I hope everything made sense. Thank you for watching. See you in the next video.